Good afternoon. I will try to go from the present, what we have seen, step by step to the future. And I start with a problematic, which is the cooling of the engine. For a decentral application in a village, in a town, in a settlement, you have, by definition, a water well or a water source. Because if you wouldn't have the settlement. It's completely dry. For this reason, it's an advantage cooling with Sunpulse engines, because they do then two things. First, they pump a part of the water which must be pumped, and they use it for cooling. But however, what happens if I want to have applications where I have no water? So I give you very short some possibilities. One possibility is that you use discontinuous evaporative cooling. What does this mean? Imagine this is a cooler, of course closed, going back and forward, which should be cooled. We have no water. We put in a low boiling liquid, schnapps. It's too precious, something like this. We duct the steam, which is created by evaporation and which is a very effective cooler. If you are evaporating on your hand alcohol, you know how you are cooling it. And with this, we go in a tank where, when the sun is going down, it is cooled and re-liquefied and being ready at new. So such a discontinuous is in principle an evaporation cooling machine in the right dimension. You can cool every place. That is number 8. And we have done such things. We have shown that we can cool air coming in with 60 degrees centigrade with schnapps to a temperature of 5 degrees constantly. And B, what we said, we are sitting on a pure ground and we are measuring the temperature towards the depths. So surface very hot in a hot country, but since the heat conductivity of the soil is very poor, so depending on the situation, in 4 or 5 meters you already find temperatures which are much smaller than 20 degrees centigrade. So you have to bring coil in it, and you are cooling the engine with an underground coil. And that's not theory, we do this in our test field in Benson continuously. And there we take another advantage. In Germany it's so that we bring in, we have a temperature which is 15 degrees in the average in 4 meter depth. And what we are doing, I showed you in the picture, we have this energy greenhouse and we bring the excess heat in a large volume. We heat it only up to 16, 17 degrees. What we did there, just short notice, we bring the heat, I showed you, from the summer into a core of 16, 17 degrees. And this temperature is largely sufficient for the winter for plants, because they like 15, 16, 17 degrees on the floor heating. And at the same time, this temperature level is wonderful cool for the Stirling engine. There we have again a double effect. We bring heat and cooling. So Earth is a good possibility. And see, what we propose for Australia is the evaporative cooling. You must know that in arid climates, I mean, those climates you have nearly no water vapor in the air, And everybody who has been in deserts knows that night times it can become cool. Huh? Even if the air is warm, the soil, if you measure it, becomes very cool. I have produced, when I was very young, was living for 7 months in Tamera and worked in such things. And I have produced an ice making machine only by radiation in the sky. So how is that? Of course, one must know that per square meter we have about 100 watts of radiative cooling. And I'm not going into details. It has to do with the atmospheric window between 8 and 14 micrometer. But the potential is that this cools down in an ideal case to minus 40 degrees centigrade, and the reality is it cools down to around 0 degree. So, how to handle this? Having, as I explained, black plastic bags cost nearly nothing. And you have the water to be cooled in a reservoir, and this water is flowing through a valve in this, at the beginning, empty bag. If a temperature sensor says to my, by the way, it's not an electronic valve, this is a heat-controlled valve, wax valve opener. So that means sun goes down, stars comes, it starts cooling, it evaporates, it says to the vessel with 20, 25, 30 degree water, whatever, what we have, the coolest possible, flow a little bit in. Then if we have set the temperature, let's say, to 20 degrees or 15 as we need, after a certain time it's 20 degrees, and it says again, now I need new water. So you will see this bag becoming thicker and thicker. And of course the maximum it can do is the 100 watts per square meter. So you put them flat, and when the sun reappears in the morning, you pump this cold water in an isolated storage, and this is used for the engine. So this is some interesting possibilities, and I stress it again, for the free lab, wonderful things to develop here. A little future, half future. Then, of course, we said it's only Sunpulse 500. The 500 is ideally suited for water pumping. We discussed this. We could have larger pumps, but then we are destroying the water niveau if we are sucking very strongly out. So 500 watt is good. And Olivier explained this morning that for an atmospheric machine, which is nice, we handle it, that the pressure fluctuation goes from positive to negative, which is nice because we are acting on both sides, working on the piston. But now, if we fill this Sunpulse with pressurized air, we will get higher performance out of the same, higher power. So that means you have seen this configuration. Yes, with a power piston here and with a flywheel behind. If we put in inside P, let's say, not atmospheric, but let's say we take 5 bars. Of course, we have to take care that our system withstands 5 bars, which is very simple for the cylinder, but which is more difficult here, so we have to reinforce this part. But that's not really future aspect, that's simply technology we can do. And then we put a dome over it, because remember we have membranes, and if we would have 5 bars here and atmosphere here, membrane would just come out like this. So we bring the same pressure here like here, and we have, if we have 5 bars, we have 2.5 kilowatt. The next aspect is that we are, tentatively we got very low in frequency, and I told you this is not law of nature. we have calculated in our simulations, we could go easily from 1 hertz, 1 times per second, to 5, possibly 8 hertz. We wouldn't go higher. Still, for an engine, a very low frequency. So if, for example, we put 5 bars in, and we have 2.5 kilowatts, and then we tripled the frequency from now 1.5 hertz to about 5 hertz, then we extract from the same engines 3 times 2.5 kilowatts. So we can play with all these parameters. So this is a pragmatic development of this engine. The future I also have described in the steps in adaptation of the engine to local materials. I think that's really something very interesting, and I must point out, after so many years of high temperature Stirling development, high tech and so, this was one of the guidelines. He said, now we have to do something which, when it comes to the places of use, and when the people say we have only wood, wood's a good example. It's very easy to build a wooden cylinder which is a renewable material. And I once calculated, if you build the system out of wood, and instead of considering the wood as burning material, you are, during the lifetime of the 20 years, you have what the nuclear people say, a breeding factor of many, many, many thousand. It's clear. The value of energy coming out of the pot is much higher than the burning value of the wood. And once it starts rotting, you still can burn it. So it's one of the ideas we should go in. And I always played with gray energy. For example, our mirrors we build. We have 100 micron thick materials, which needs nearly no energy to produce compared to big glass plates and steel structures. And there we have a very fast recovery of the gray energy. Evidently, in such pots, not. But we have other advantages. So if we wanted to build with the thermodynamic principles we learned, very lightweight, even much more efficient engines. I told you, I showed you at the beginning this, I think, enough exciting Carnot curve, which gives you 21% at 80 degree delta T, which is at, if I remember well, we were at 500 at 77% efficiency, and at sun temperature, nearly 100%. So, and we realize that I didn't say clearly, that is the potential, and if you realize something in technology, you will never reach the potential, the theoretical value. And there we speak about Carnotization factor. So if the Carnotization factor would be 1, we would be God, because we built engines at the perfection. We cannot. I told you that cars have Carnotization factors 15-20%. We already reached Carnotization factors of 50% with this engine. And I tell you, it was a hard work, because when we started low temperature Stirling engines, it was not so. And there were worldwide groups in Japan working. They spent millions and millions and millions. And we are really proud. It's simple, but we really are the best worldwide. The competition is not reaching half of it. I'm not saying this to sell you something. But now comes the next point. Since we have seen we could reach 50%, why wouldn't we reach 80%? So I tell you, once I was sleeping here at the beach, and I'm always going here in Tamera is a wonderful place for meditation and thinking. Because they're wonderful people, as you see, and you are inspired. And after, we should always, even now, do this. After 1-2 days of seminar, you have a lot of things going around in your head. And then comes the next day and more packed on it. So it's a moment you should say, hey, now I go. Everybody has another method. I want to go completely lonely on a beach and restart thinking. And there I invented what I call the pulsator. And this is something very exotic. I can just give you a basic idea. If you want to reach 80 or 90% of the Carnot, you need new principles of heat exchange. Because the limitation factor, when you have seen this configuration, heat exchangers, eccentric, is if I have, let's say, 120 degrees in the heat exchanger, or each other number, it will not result in 120 degree in the air, unfortunately, because we have delta T by exchanging, and the delta T now is about 15 Kelvin. That means the 140 or 120 degrees result in 100 degree or 105 degrees practically. If we could reach higher heat transmission, we would do fantastic things. And that's what was the basic idea. And the basic idea looks like following. Imagine you have, this is not simplified now, huh? You have a vessel filled with a hot liquid, another vessel filled with a cold liquid, and inside you have the pulsator. And the pulsator is nothing else than large plastic bags filled with air, but one times filled and the other times empty. A breathing bag. Huh? If you have a breathing bag inside of a hot or cold liquid, the reversed stream of gas and the thin walls and some other effects create such a wonderful heat exchange that we have no longer 15 delta T through the walls, but 2. That's what we have reached. And if we apply this now to a Stirling, which I'm not going to explain in detail, you will see it as next generation, we will have Stirlings running at 80 to 90% Carnot. Then we will be unbeatable, because such a system, if you add now the cold storage here, regenerator between, and you pump the bag with the power piston we have spoken. So the power piston has 2 functions. When it's going inside, it's just displacing the volume of the air. It becomes flat here. On the other side, the piston is opening. So this is displacer piston and this is a power piston. Such membranes need practically no mechanical force to deploy and to fold, if you compare it to mechanical installations. The next point and the third point is that in this PV diagram we have, I think Olivier said it, during expansion and recompression we should have isothermal conditions. It means it should not cool down by expanding, and it should not become hot by compression. Then, if you bring this in the thermodynamic formulas, then you have an ideal Carnot engine. And this isothermalization of a process in a Stirling is very complicated, as Uli for sure agrees. But if you have bags sitting in a liquid with a high heat capacity, it's practically 100% isothermal in both of this. So what we are doing at the moment, we have developed the bags, was a mess because you have to play around with many details. It starts working. And then we said, now we have to concentrate for Sunpulse because we have the seminar, we are a small team. So I am at the moment running also around the world to get funded the next steps. And we will be able to build with this system really small engines delivering 10 kilowatts at very, very high level. And this is for me the real breakthrough of what we began here, but not to say you wait until we have this. It will come. It's like a generation. It's like when the semiconductors came. If you would have said, I wait until the semiconductor is in cost down, you know it, you would never have done it. So you have to start, and all you hopefully coming into our extended seminar, becoming partners, the partners will automatically profiting from all other steps we are developing. I always wonder a little bit about me, not to praise me, but I'm a little bit crazy. And the only thing I can do is invent things. And I always think, now I am old, no, I cannot have a better idea. But this was really wonderful. And the best test was, it's a beautiful test, always coming with new ideas. I go to Olivier and he says, this is bullshit. It will never work. And then he came the next morning, he said, it's very rare he is doing. He said, Jürgen, oh. And I said, okay, now you come and I invite you, you become co-inventor because there are certain things I don't have done, and he brought it brilliantly in. As you can see, he is very good basic thermodynamic engineer. So okay, but now comes the storage. Three things. I think we demonstrate that we can fulfill nearly every need of energy. I told you that this will be more efficient and extendable to larger powers, because here we will be able to build engines of 100 and 200 and 300 kilowatts. This is going more to the urban and industrial stage. But storage. So when I said, okay, use hot water or hot vegetable oil in Africa, it's beautiful. And I want to say you are blessed. I spoke to this solar king. He's a king and he's solar. Yeah, and you are blessed because you can do this. Because the sun is shining statistically nearly 100% the next day. And that's what you are suffering now. So you take advantage. We in Germany, we cannot say the sun shines next day, we need other type of storage. So it must be a thermochemical storage. I give you a very short view what we did, and you will immediately understand. Evidently, I think when you had been in school, in chemie, in chemical education, at one time you came to the point to learn something about the reaction between sulfuric acid and water. Someone learn? The first thing is never have sulfuric acid in a glass and put water and look over it. You are blind. It's immediately steaming out. Very intense temperature. That means here we have sulfuric acid, which costs nearly nothing, by the way, because it's one of the cheapest chemical liquids existing. Here you have H2O, water. Here we have what we call a reactor. We pump in the proportion 1:1 sulfuric acid and water in a closed container where it reacts. It's creating intensive heat. It's creating heat up to 220 degrees centigrade. And of course, we extract this heat we go to our pulsator or Stirling engine, whatever. The energy content is huge. If you mix 1 liter of water with 1 liter of H2SO4, you create the heat which is equivalent to 0.1 liter of oil. But this is reversible. Well, once you have burnt the oil, it's finished. You have to dig the next hole, I don't know, make the next war for oil. Here, you have containers, and when you have no sunshine, night, clouds, whatever, you create your heat by this thermochemical reaction. When then the sun comes out, you have, I should have designed the third vessel, which is now a mixture of H2SO4 and H2O. So when you have, here you have 2 liters if you put 1 liter to 1 liter. And this is no longer reacting. But now you put an heat exchanger inside, and as you know, H2O has a boiling point at atmospheric pressure of 100 degrees. Whilst H2SO4 has a boiling point over 200 degrees. So, solar heat out of our collector system boils out the water. We take care that there is no acid coming dynamically out. We did this, so I'm not speaking theory, we have done this. We take an active carbon shield through which the water vapor goes. Yeah, and we recollect by condensing this water, and we have again H2O here, and we have again the concentrated H2SO4. Yes, and we have another advantage, because this energy we put in is used to produce steam. By condensing the steam, we are recollecting the energy of evaporation. It's a condensation energy. And at a niveau, if we make a counterflow heat exchanger, we will have again nearly 100 degrees centigrade. So this baby, compared to, it's my love, and it's my pity that I'm poor like a church mouse. I cannot do it, but it will come. So this we compared now again to electric batteries, compared with the future pulsator will beat all the electric storage systems nearly by order of magnitude. And again, we are, okay, you could say H2SO4 I don't want to swim in it, that's true. It's very corrosive, but I have a good news for you. That we learned, it's a long time ago we experimented with this. We learned that the fluoropolymers we one day will produce in Africa, promised, are completely chemically inert. So if you have a bag inside H2SO4, even with water, it's more aggressive. If some water is inside, nothing happens. So we can, instead of having very expensive ceramics and special measures for our tanks, we can have it wrapped with inner layers, liners. So that's a little bit future, 3 minutes more for future. We have spoken, if you understand the principle of a Stirling as a black box, I call it, a thermodynamic transistor. Why? Because what we discussed in length, this displacer piston, which takes a small fraction out of the energy of the flywheel to move back and forth, is triggering a much stronger heat difference potential in power. To give you this in numbers, one of the reasons why we have slow motion engines if we are in the range of 1 to 5 hertz, as I told you, the displacement energy for the air is about maximum 10% of the energy lying in the flywheel. If you go to a high temperature, high speed, due to the fact that the gas viscosities, the cinematic losses in gas, are augmenting exponentially, there, for fast-running engines, it can be up to 40%. Okay, but knowing this, give you a perfect example. I think I spoke, but not everybody has heard it. Some people say, okay, here is a deep well, and the women coming from, so this should be a woman, it's not look nicer in reality, going here and has to pump water with a hand pump. And since we have a very deep level, she needs a hell of muscles. If now, and she wants only to pump because in this well there's not so much water, only when she takes water out and bring it back to the village it goes. So if you put a very simple Sunpulse and you are not coupling back the flywheel, even without flywheel, and you have a little lever which is displacing this as a displacer, then suddenly with 10% of the energy you normally needed, you pump the same amount of water. So this is not future, I have done it in the lab, I called it yes, a thermodynamic transistor, and there's a lot of possibilities. Imagine, you look behind you, solar energy. Not the light. This is the oscillation of the plants. This is transformed solar air current into a periodical swinger. And you have, I did this, I called it wind tree. I put a lasso over a nice tree, and I saw that I could extract, depending from the wind, from 500 watts to 2 kilowatt of power. You must try it. Even with the smallest wind, you will not stand on your feet. Imagine now you have a combination of natural swingers and you put extremely simple flywheel-less boxes and you drive them by the oscillation. You are triggering the thermodynamic function. That's a nice thing. You can do the same thing if you have a higher level potential energy of a lake and you want to use a good portion of this water because a good reservoir to make energy out of it, but then you have to pump it back. Then you can use the same principle. You let just this system being pivoting with a little bit of water flowing over it, and the large energy is coming by the potential brought by the sun to it. Okay, so I think it's fine, and there are many other things.